So I just want to welcome you all. I'm excited to welcome Maddy Schwarz from San Francisco Bay Bird Observatory, and she's going to be talking about snowy plovers today. So if you didn't read her bio on the website, she's the Snowy Plover and Least Tern Director at San Francisco Bay Bird Observatory and holds a Bachelor of Science in Wildlife, Fish, and Conservation Biology from UC Davis. She became connected with SFBBO while assisting with plover surveys. So if you're out there wanting to help with wildlife surveys, there's a path for fun work ahead. When she's not working, you can find her reading, rock climbing, or hanging out with her cats and her snake. So she and her team are doing really important work tracking the distribution and abundance of snowy plover in the lower South Bay. And she does that work with other colleagues around the Bay to really understand what's happening with snowy plover in the whole region. So I want to remind folks that over the last year, the South Bay Salt Pond Project has supported surveys so that we can help document snowy plover numbers and nest success as part of our own adaptive management plan that helps us track our target to contribute to the recovery of snowy plover. So Maddy's going to share where we are in regard to that target. And with just a little spoiler, it's good news. So I've had the fortune to see your slides this morning, and they're really good. I know you're going to appreciate our talk. So I'll let you take it away, Maddy.
Okay, yeah. Thanks so much, Donna, and thanks to the Salt Pond Project for having me and giving us the opportunity to talk about plovers and spread some knowledge. I apologize, I am sick, so if I cough or if my voice gives out, I'll try to mute myself. Also, my webcam started acting up yesterday, so if my video suddenly dies in the middle, we're just everything's a little bit messy, but I'll do my best. So I'm gonna share my screen and let's see. Oh, let's not have that. And not have this either. Okay. Um, and I will present. Come on, there we go. Okay.
Good, thanks.
Yeah. All right. So welcome to my talk. As Donna said, I'm Maddy Schwarz. I'm the Snowy Plover and Least Tern Director at SFBBO, and I'm very excited to talk to you all about plovers. So this is just an overview of everything that I'm going to talk about today. First part, we're going to go over just snowy plovers, what they are, how to identify them, a little bit about their biology and ecology. And then in the second part, I'll talk about where they exist in the bay and some of the threats that they're facing as a species. And then after we've gone over that, then I'm going to use the 2024 breeding season as kind of a snapshot of, so like, how are they doing against the threats and all the things that are happening around them. And then the last part will be, we'll zoom back out and we'll put this season into the larger context of all of the ways that us as managers and the Salt Pond Project and here us at SFBBO as scientists are trying to help the plovers. And then finally, last part will just be a quick section on how you can get involved and help plovers yourselves. So without further ado, here's an adorable photo of a plover. Donna said I should make sure to have cute baby photos of plovers. So we're delivering right off the bat. All right, this is the Western snowy plover. Its Latin name is Anarhynchus novosus novosus. The genus name recently got changed from Charadrius to Anarhynchus. They are a small ground nesting shorebird that's approximately 6 inches tall. They weigh about as much as 8 quarters, and they're about the same like size and volume as a soda can. So they are quite small. And this is what the adults look like. During the breeding season, the males will get these dark patches on their shoulders and their forehead, whereas the females stay much lighter. And then in the winter, the males lose the black markings, and the males and the females look the same, and the juveniles look pretty similar to them as well. So if you were to go out and look for plovers right now, which there are plovers around right now, spoiler alert, you can go out and find them. You would not be able to sex them. You would just know that they were snowy plovers, and that would be all you could do right now during the winter. This is what the chicks look like. The chicks are precocial, which means that they can move around independently and forage for themselves within just a couple hours of hatching. So on the far left, we have a chick that just hatched. It's still wet from the egg. And then in the left middle, we have some chicks that are a couple hours old. They still have their egg tooth, but they're dry. And that means that they're probably ready to leave the nest. If it's a warm day, they're already going to be out and away, even though they're probably only like 6 hours old. And then the middle right photo is a chick that's probably around like 2.5, 3 weeks old, starting to look a lot more like a bird, but still a little scraggly around the edges. And then the rightmost photo is a juvenile that is fully fledged. That's what they look like once they can fly. So this is a map of the species range. And as you can see, there is also an entire interior population of snowy plovers. Here on the West Coast, we deal with the subspecies, the western snowy plover, Anorhynchus novosus novosus. There's also the interior population, which is just Anorhynchus novosus. And so this is what the western snowy plover population is. It runs from Southern Oregon all the way down to Baja California. And so you can see that here in the bay, we're basically smack dab in the middle of their range. And throughout most of their range, they nest on beaches. So kind of the habitat that you can see in the leftmost photo, uh, beaches, sandy beaches, um, river bars, salt pan. But here in the San Francisco Bay, their habitat is a little bit different because we don't really have that many beaches within the bay, but we do have salt ponds and man-made habitat. So we have salt pan and salt ponds, levees, and place dredge material. That is where you will find plovers within the San Francisco Bay. Plovers are migratory. But they're kind of like strangely migratory. They're not a typical like, oh, go north in the summer, go south in the winter. It's not so much like that. The interior population in the winter will disperse to the coasts. They don't want anything to do with Midwest winters, so they will go to the Gulf of Mexico and they'll also go to the Pacific coast. So right now we do have interior snowy plovers that are here, but they don't breed with the Western population. They'll go back into the interior during the breeding season. But then the Western subspecies, they don't so much migrate as more disperse away from where they hatched. It's so interesting. It seems like individual birds have their individual winter spots that they like to be. Like we have, because we individually banned our plovers, we know where like multiple birds like to hang out for the winter and they go to the same winter spots over and over. So some birds go to Oregon to winter. Some birds go to San Diego to winter. Some birds go to Monterey Bay. Some birds go to Half Moon Bay. Some birds just stay here and hang out. So there's kind of some movement up and down the coast throughout the winter, but it's not a traditional like, okay, and we all leave to go to a wintering site. It's more a dispersal. So since we're in the winter right now, I'll talk a little bit about the plover winter numbers. Every year we do a survey in January. We're doing our one for this winter in just a couple weeks. The week after next week is the winter window for this year. And so I don't have the numbers for this year yet because we haven't done it yet. But last year was the highest number of birds that we've ever had during the winter window, which is really awesome to see. Had a high of 463. And yeah, there's a lot of variation from year to year, but overall the trend is going up. And so, like I mentioned before, the birds will uh, go to their wintering areas and they'll hang out in loose flocks together. And also, like I mentioned before, we have both coastal and interior birds right now in the bay. And they'll be foraging and roosting together because during the winter they have to rest and build up their fat reserves so that they are ready to go for the next breeding season. And so winter habitat is very important. Sometimes it kind of gets overlooked, like when you're doing bird management, everything, all the focus is usually on breeding, but the winter habitat is still very important because it's like where they're preparing to do their breeding. But now let's shift into the breeding season. In just a couple months, the breeding season will start. It starts on March 1st and it runs through September 15th. So it's a very long breeding season. Um, and since the birds nest directly on the ground, their only defense against predators is to use camouflage and be very cryptic and hide against the substrate of what they're nesting on. So you can see in that right photo, the birds are the same color as their background, and that is their basically only defense. They don't mob predators. They don't defend their nests really against predators. If a predator comes by, they will just hop up and run away and try to act like nothing was there. Just be like, no, 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 there was nothing there. I'm not being suspicious. You're being suspicious. That's their strategy. So that means that the nests also have to be very camouflaged. This is what the nests look like. Typically, it's 1 to 3 eggs. um, Vast majority of eggs are or vast majority of nests have 3 eggs. Occasionally we'll get a 2 egg nest, but vast majority is 3. And they're incubated for around 30 days. So for a full month, the birds are sitting on the nest. And the adults will share incubation duties. So during the day, the female will be incubating, and then at dusk they switch and the male incubates. So you can see just from the contrast, even though this one's in black and white, you can see how much darker the male is. You can really tell that that's a male on the nest and that's a female. Doesn't have the dark shoulders or the dark forehead. Um, and then once it's dawn, the male will switch off and the female will hop on. Um, but once the eggs hatch, then the male takes over rearing the chicks. The female will leave and try to find another male to start another nest, and the males will take care of the chicks. So it takes the chicks around 4 weeks to fledge. So it's a long process, it's a long job that the male signed up for, but he's up for it. And his main job during this time period is to brood the chicks, because since the chicks do not have all of their flight feathers, they get cold. They're just covered in down. They get cold very easily. So mainly what the male is doing is keeping the chicks warm. You can see in the top photo, that's what brooding looks like. They look kind of terrifying, like a bird, like a lumpy bird with way too many legs. But then the chicks will pop out and you're like, oh, so cute. Like the bottom photo. And the males do not actively feed the chicks. The chicks are more than able to forage for themselves, but the male will lead them to where the best foraging habitat is and try to lead them to like safer areas. And even though the chicks are very mobile when they're younger, they will like freeze and just try to hide and blend in as opposed to trying to run away. Whereas once they're a little older, uh, that's when they'll run away instead of just freezing and dropping to the ground. So this is a snapshot of the breeding population. So similar to the January survey, we also do a survey in May, a week-long survey in May. And this is a very important survey because it's what Fish and Wildlife uses as our baseline for whether we're meeting our recovery goals. So you can see that at the top of this graph is the goal for the Bay Area. The goal is 500 birds, which you can see we're not there yet, but the trend is going up, the line is going up. And down here, you can see that we have this other paler line at 250, and that is the Salt Pond Project's goal. The Salt Pond Project, when they were writing their adaptive management plan in 2006, there was around 200 birds that were counted during the breeding window survey that year, and the Salt Pond Project set the goal of reaching 250 breeding birds within the footprint of the Salt Pond Project. Which is an ambitious goal. I'm going to talk about this later, but the Salt Pond Project knew that they were going to be impacting plover numbers, but they didn't want to leave plovers out to dry. They actually wanted to encourage plovers and encourage the plover population and increase the plover population. And so they set that 250 breeding birds goal. And as you can see, for the last 2 years, that's the first 2 years that we've been consistently over that number. That orange line is only birds that were observed on Salt Pond Project land. And you can see that it's, yeah, 2023 and 2024 are the first 2 years that we've been significantly over that goal. We were like a tiny, tiny bit over it in 2010, right there. And then it dropped back down the next year. But for 2 years in a row now, we've met the 250 goal, which is really great to see. So now let's talk more about the habitat and management. Um, oh, I think this is supposed to be part two. Oops, I'm sorry. Ignore that. It's supposed to be part two. Um, let's talk about habitat within the bay and this crazy puzzle of habitat of like animals and wildlife and humans that a lot of us are so passionate about. Um, so this is a map that is actually a map that was included in Salt Pond Project planning documents from 2000. This is a map showing the Bay Area prior to colonization. So you can see that the landscape was drastically different. There were many indigenous tribes that were using the bay, and the habitat of the bay was by far and away primarily tidal marsh. You can see this kind of like medium brownish green color is everywhere. It was mostly all tidal marsh. And the only area that was a naturally occurring salt pan was over here, kind of in like where Hayward is now. So that means that there was not very much plover habitat in the bay prior to colonization. Because if you remember, the plover is like this kind of brown, dry, sandy area, and if you have all this beautiful, lush, green, blue salt pond or tidal marsh habitat, that doesn't really work with uh, the plover's monochromatic vibe, right? Now, this is what the bay looks like by the year 2000. You can see that tidal marsh color is almost almost completely gone, whereas the salt pond color, that peachy color, has really taken over, and there's so much more plover habitat in within the bay by the year 2000. Um, just because, like, this is a map from 2000, so this has changed. There's already been more stuff that's been restored to tidal marsh since this map was created. And not all of this is plover habitat because just because something's a salt pond doesn't mean that it's managed as dry. There's a lot of salt ponds that are managed to be completely wet for migratory waterfowl and water quality and stuff like that. But overall, still much more habitat for plovers specifically after colonization. So this is what things currently look like. These are the map on the right shows all of the locations where plovers bred in 2024. All the black outlines are where we had nests, and we divide the we divide all of our sites into 7 major complexes. So in reverse anti-clockwise order, we have Ravenswood and Menlo Park, which is part of the Salt Pond Project. We have Alviso in San Jose, which is part of the Salt Pond Project. We have Warm Springs in Fremont, which is part of the Salt Pond Project. We have Dumbarton in Newark, which is not part of the Salt Pond Project. We also have Coyote Hills in Fremont, which is not part of the Salt Pond Project. We have Eden Landing, which is part of the Salt Pond Project, and Hayward Shoreline, which is not part of the Salt Pond Project. So as you can see, the majority of the places where plovers breed currently are on Salt Pond Project land. So you might think that based on the previous slides that, oh, plovers are so lucky. Like they're one of those species that just does really well with like when there's a lot of humans in an area because they benefited so much from getting so much more habitat. That's not quite true because the species that really do well in human changed environments are predators, like invasive red foxes, like common ravens, to a greater or lesser extent, peregrine falcons. And predation is currently the most devastating threat to plovers, especially in the bay. That is how the vast majority of why the vast majority of our nests fail. But there's also disturbance. So on the two left photos are more what disturbance looks like for the rest of the range. Fortunately, we don't really have beaches or anything like that. But plovers are incredibly skittish. They flush off of their nest really easily. So even if there's public trails nearby, sometimes the birds are acclimated to it, but sometimes they're not, and it discourages plover nesting. They won't nest close to public trails. And then also drones are a problem that we deal with in the bay. There are not drones are not allowed to be flown over Don Edwards National Wildlife Refuge land, but as I'm sure all of you know, people like to break the rules, and we do see drones on occasion. So we do have drones, we do have off-leash dogs, we do have people going off trail. Um, so disturbance is still an important issue in the bay as well. And then finally, habitat loss is a big problem throughout the range. Sea level rise, beachside development, like you can see on the rightmost picture, that is a huge issue in other parts of the range. In the bay, we mostly have to deal with invasive plants because if any of you work with invasive plants, I know Martin's here. If any of you work with invasive plants, you know that once they start showing up somewhere, it's so hard to get rid of them. We have big problems with the ice plant. Uh, yeah, so invasive plants are also an issue. And then now we get to the most interesting part of plover work in the bay, which is the salt pond project. So the salt pond project, as I'm sure a lot of you know, is the biggest tidal marsh restoration project on the West Coast. They aim to open around 15,000 acres of salt pond habitat to tidal marsh. And it's at least a 50-year project. You can see in these photos the really cool evolution of like, okay, we breach a levee, we breach this old degraded levee. This is what the pond looked like prior to the breach. And within just a few months, we have all this great new vegetation growth. So it's a very effective restoration strategy because there's a lot of reasons why tidal marsh is extremely important. There's lots of endangered species that use tidal marsh, like salt marsh harvest mouse, like Ridgway's rail. It's great for flood protection. It's great for like fighting against sea level rise, and it's also just like an important environmental justice and like moral obligation to try to heal such a huge and like drastic scar of colonization. Like it's really the least that we can do. But because life is extremely complicated, there is also, and because life finds a way, there is also many species that have moved into the salt ponds since colonization, as I just went over. And so as you restore ponds to tidal marsh, you're decreasing the dry pond breeding habitat for plovers and terns, and you're also decreasing the winter habitat for migratory waterfowl. So we love tidal marsh restoration, but oh no, what is going to happen to the plovers and terns? So I'm leaving you on this cliffhanger. Now we're going to talk about the 2024 breeding season. So this is actually part three. Yay. This is the 2024 San Francisco Bay Bird Observatory Snowy Plover team. From left to right, I have Josh Scullin, Jesse Wentworth, myself, Lauda Chavez, Parker Kay, and Jeremy Reinhard. Love all of these people. Hardest working group of people in the game. Could not have made it through this season without them. Huge shout out to everybody at SFBBO who works on plovers. So, what did we spend our entire summer doing? Well, we had in total 396 nests across the South Bay, which is a huge number of nests. If that was the number of nests that we had monitored, it would be like way above and beyond the highest number of nests that we've ever had. But because plover nests are very hard to find, if any of you have ever tried to survey for plovers, you know, the 68 of those were found as inactive. So we either found them as a brood or we found them as known depredated. So there was like fresh yolk and eggshells like around the nest. So when you take away those 68, that means that we monitored 328 nests, which is still a lot of nests. It is, in fact, the second highest ever number of nests that we have monitored throughout the history of SFBBO's Plover program, second only to 2017. But just because there was a lot of nests doesn't necessarily mean that you had a good year, because if the birds are just starting a nest over and over again that's getting depredated within a week, then the birds are wasting energy, you're wasting your time. Like that's not great. So let's look at our failure rate. So we had, of those 328, 138 nests failed, which is 42%. And like I said, depredation is the biggest problem within the South Bay. Of those 138, 132 were depredated. So 40% depredation rate. Um, and then there were six more that failed due to other issues. Either it was an all dead clutch, or one nest was abandoned, one nest was flooded. But that means that 177 nests hatched. So 54% of nests hatched. And when you look at average our average hatch rate across the last 20 years, our average hatch rate is 53%. So this is a pretty solid year, because we had a lot of nests and like a slightly higher than average hatch rate. So a lot of nests, average hatch rate equals a good year for plovers. And then there's another 13 nests that were unknown. We couldn't determine their fate. This is what everything looked like geographically. So you can see that Eden Landing is by far the biggest proportion of where breeding was, followed by Ravenswood and then Alviso. That's very typical. This is typically the top three that we see in this order. But I do want to just shout out the other complexes because they did well this year, by like their own standards. It was a very even split between the other four complexes. So that was nice to see. And then this is the same information, but just split up by pond instead of complex. So you can see that the top 10 ponds account for 80% of nesting. So E14, A13, R3, R1, A22, E6B, E16B, A15, Patterson, and E13, all of which I have highlighted in black on the graph. Only those ponds account for 80% of the nesting. And then there's 19 other ponds, all with less than 10 nests, that they account for the other 20%. So I thought that was interesting to look at. But now let's look at what the most productive ponds were by hatch rate. So if we're here, we see that E14 had the highest number of nests, closely followed by A13. But when we look at the hatch rate, we can see that E14 did not have the best hatch rate this year. It was only a little bit over 40%, whereas the hatch rate at A13 was close to 80%, which is really amazing to see. So that means that A13 wins Best Pond of the Year award for 2024. And so now that was my little summary of the 2024 season. So now we're going to zoom back out. We're going to put this year back into the context of how we're helping plovers, how we're managing for them. And here I have some pictures of Dave. I told you there was a picture of you coming up. A picture of Dave, a picture of myself with some oyster shells, which I will talk more about how those are important right now. So, like I mentioned, the Salt Pond Project set a goal to increase the number of plovers in the bay to 250, despite the fact that they were going to be removing plover habitat by breaching levees. And so, to do that, we knew that we had to enhance the plover habitat that was remaining. So, what we decided to do was to try to create set aside ponds that would not be breached and set those aside for plover habitat and enhance them with oyster shells to try to increase nesting. So the oyster shells provide camouflage and cover for breeding plovers, which I will demonstrate with this visualizer. So the background picture is a shot of E14 where the majority of our shell plots are. And these oysters are just oysters that typically come from restaurants around the bay. We partner with the Wild Oyster Project, and because they collect shell and cure shells from restaurants. So we have all of these it's called blank shell once they've been cured in the sun for like around 2 years. So we have uh so when we get blank shell, we'll spread it on the ponds and we'll create a shell plot like you can see in the background. And then here in the foreground, we have a beautiful glamour shot of a female plover sitting on a nest. And what you can see when I shrink this down is that almost immediately the plover disappears into a sea of white blobs that looks indistinguishable from the rest of the sea of white blobs. And so you can tell that it's much harder to pick out a plover in this visual field than it would be if the shells were not there. So that makes it harder for the predators. It also makes it harder for us. But, we're in this for the plovers, not for ourselves. We're willing to make our lives harder to help the plovers. So these are the shell plots that were spread at E14. In 2008, we spread the three square plots on the west side of E14 as test plots to make sure that the plovers actually preferred nesting in those plots than they did on the blank or the unshelled areas. And we determined that they did prefer nesting there, so we expanded the shell plots after 2014. We expanded the shell plots to have one big one in the east and one big one in the west. And that has turned E14 into the most productive plover pond in the South Bay. So you can see you can see in 2012 to 2014, over here is when the pilot shell plots were active, and then 2015 is when we spread the big the big plots, and you can see that the number of nests like doubled immediately. And then we have like the heyday of E14 from 2015 to 2019, and it seems like it's kind of maybe slowing down a little bit. We had an uptick. We had an uptick in 2024, kind of back up to like 2020 levels. But even in 2021, when we barely had any nests on E14 comparatively, that was still 17% of the nests in the South Bay as a whole. So even in E14 slower years, it's the most important plover pond by far. And the hatch rate at E14 is pretty consistent with the hatch rate across the entire South Bay. So we are increasing the number of nests in this area, not necessarily increasing the hatch rate, but we are increasing the number of nests. So that means that plovers will preferentially nest in shelled areas, and so there's opportunities to create more shelled areas. We sort of feel like E14 has been subject to a lot of predation pressure because like it is such high quality habitat. The predators have kind of learned that it's the best spot and it's where the most birds are. So if we're able to create more area, like more ponds that are just as high quality as E14, then it would take the pressure off of E14, and we would be able to have just as high quality nesting in other sites. So the other thing that you can do is you could increase the amount of predator control. So these are shots that we've gotten from our camera traps that we put on nests, all of ravens depredating nests. And I know that lethal predator control is a bit of a sticky subject, but I'm here to tell you that it does work. And I wanted to use this year as another example to show that. So in Alviso, like I mentioned before, we had an amazing year at Alviso. 75% hatch rate across the entire complex, which is crazy. Usually that complex does not do anywhere near as well as it did this year. And in part that can be attributed to there being more habitat at Alviso this year. But the bigger story, I think, is that USDA was able to remove 109 ravens from Alviso and the surrounding area compared to the 7 that they removed in 2023. And so you can see that the hatch rate at Alviso jumped up by like over 30%. which is really amazing to see. So predator control does work. And then finally, I'm just gonna talk a little bit about how you can get involved in plover work. Um, so first thing you can do is you can volunteer. We have um, we have a mud stomp coming up in just a couple of weeks. January 25th at Menlo Park, we're going to be spreading oyster shells that were donated by that we worked with the Wild Oyster Project to acquire. We're going to be spreading shells at a pond in Menlo Park. The information for that should be on our website soon, but save the date now, January 25th at Menlo Park, 8:30 to 11:30. Come out and volunteer and help spread shells. Um, Also, you can be part of the solution. So if this presentation inspired you, if you were like, wow, I learned so much about plovers and I had no idea that there were so many in the bay, like tell your friends, tell your family, tell the people that you know that have dogs. If you have a dog, don't take dogs places that dogs are not allowed to be. Keep your dogs on leash. Don't fly drones. Stay on trail. Lots of ways that you can be responsible recreation recreationer. I don't think that's a word. Whatever. Lots of ways to do that. Oh, and then the last thing is you can if you have any more questions about me, if you're really or if you have any more questions about plovers, if you're really excited about plovers, you can email me. I meant to add the Snipple band reporting email. If you're a birder and you take photos of plovers and you have any banded plovers, there is a Google group that you can report your bands to, and uh, every that goes out to every researcher, every plover researcher across the range. So no matter where your plover is from, someone will respond to you and tell you where the bird that you saw is from and where it hatched, which is really cool opportunity. So if you have any band combinations, you can report them to the Google group. I will put the email to that in the chat after I'm done presenting. Um, and finally, I just want to end with this graph again, show that things are going in the right direction, that all of the work that people are putting in, that the Salt Pond Project, that SFBBO, that CDFW, that the Refuge, there's so many people who are working with plovers in the bay, and all of that work appears to be paying off. And I hope that this presentation has inspired you to be a plover lover. And with that, that's all I have. I got through that faster than I thought I was going to. So we have plenty of time for questions. Um, yeah.
That's terrific, Maddie. Thanks so much. Really great presentation. So we do have plenty of time for questions. This is actually, your presentation was perfect because we like to save 10 or 15 minutes for people to chat with you. So yeah, go ahead and raise your hands or unmute if you want to ask Maddie any questions about plovers.
I'm looking at the chat. So someone said,
Yeah,
um,
the question about the time it takes um, for the oyster shell to dry. I think Samuel said 2 years or so. I don't know if you have anything to add to that.
yeah, I mean, that's the Wild Oyster Project's role, not mine, but I believe it is 2 years. I think that's just because it takes a long time to like make sure that anything that could be growing on the oysters is dead because we don't want to spread anything invasive or any sort of chemicals or diseases or anything like that. So I think 2 years of sitting out in the sun is about what they need to make sure that they're good and blank. But if someone from the Wild Oyster Project has more to say about that, I'm happy uh, to let them talk.
Yeah,
Yeah, hi,
certainly.
I'm Samuel. So I recently partnered up with Wild Oyster Project back in January. I'm going to West Valley College for my park management degree, and I just finished my certification program as well too. So it does take 2 years for the shells to cure. The ones I get are actually from Pier 402 in Midtown by Midtown Safeway off of Race and San Carlos. So I bring them to Taylor Street Farms and I let the chickens, because we have a chicken coop right here off of Taylor and 87. So I let the chickens eat them and cure them, and then that way they get some calcium for them as well too. I probably leave them there for about like 2, 3 months. That way they can just pick them fully, and then over in Alviso along the levee, I have a pallet that I put the shells in there, and then that way they can just cure. Especially in the summertime when it gets really hot, all that heat helps to kill the bacteria. And then once they call me and say, "Hey, we're ready to start taking some from Alviso," now you guys don't have to go all the way to the San Francisco or East Bay locations. You can get them directly from Alviso. So that was kind of the whole plan on it. So 2 years.
Okay, cool. Thanks.
While we're on oyster shells, Margaret asked, what's the recommended density and placement of oyster shells? It looked like you placed them in clusters, or was that right?
Yeah, so that's such an interesting question because that was something that was coming up. That's something that was coming up like internally within SFBBO just a couple of weeks ago. So there was probably a recommended density back in 2008 when we spread the pilot shells. I'm sure that there was some sort of density that was set. I don't know what it is off the top of my head. At this point, we kind of go because we know what the shell plots are supposed to look like. So we kind of go based off of vibes, honestly, when we're spreading new shell plots because we know what the density is supposed to be. And the goal is to just go for like randomness. So we're not purposefully putting them in clusters. We want it to be a very even distribution. Sometimes they kind of end up getting bunched into clusters because when the water levels come up in the winter, the water will like push them kind of a little bit into areas. So there will be gaps from where the water has like flowed through the pond. But for context, we spread like a 6-acre plot on a pond last year, and that took around 3,000 shells. So, or 3,000 pounds, 3,000 pounds of shells. So 3,000 pounds to 6 acres is about the density. I don't know what that actually works out to, but 3,000 pounds to 6 acres is about what we ended up with. And yeah.
Yeah, and Ben just added 5 to 8 shells per meter squared was the density.
Okay.
About.
Yeah. Thanks, Ben.
Let's see. I want to try to jump back. There's a lot of comments. This is really great.
Yeah.
I guess there was an early question about how the reasoning behind the 500 and 250 numbers as a goal for snowy plover. And the 500 is a recovery unit goal for the Bay Area. I think that was set by Fish and Wildlife Service. Is that correct? And Rachel is on, so she may be able to answer this better than I.
Did someone just start sharing their screen?
Yeah, I think it's Doug. You accidentally shared your screen with us, so we're all seeing your
emails,
your email. So yeah, if you could unshare your screen, that would be great. Sorry to interrupt everyone.
All right, Donna, what was the question again for me? This is Rachel.
The setting of 500 for the recovery unit goal and 250 for the project.
Yeah, that was done. Well, my camera doesn't turn on. That was done before I was around, but there's a pretty lengthy process around the early 2000s where they set up the recovery goals based on the habitat that was available at the time, and then with the idea that there would be ways to improve or increase plover habitat to be able to downlist them to threatened and then downlist them to endangered. And so it was a pretty hefty goal of 500 for the area, especially considering the very small number of plovers that were present when the plan went into place. There was, if you looked at Maddy's original graph, it was way down on the far left of those numbers. So 500 was a really lofty goal at the time. And it surprisingly and excitingly, we're moving up in an upward trend. But yeah, that's how it was done. And then Maddy did a great job kind of explaining how we got to the goal for 250 for the South Bay Salt Pond project.
Yeah, I think I'm not sure because the goal, the adaptive management plan for the Salt Pond project was written in 2006. So I was a 6th grader, so I'm not sure exactly what the rationale behind increasing from 200 to 250 was. But I think I do know that everything from in the adaptive management plan was based off of the 2006 baseline, and the 2006 baseline for plovers was 200 birds. And so I think they probably looked at that number and thought, okay, like 50 is a reasonable, like respectable increase if we increase effort, if we increase management. That's a respectable increase to make. That's not my guess. You can ask Lynn Trulio. She's the person who wrote the adaptive management plan. I'm sure she could tell you all about it. Yeah.
So I'm going to try to get to a bunch more questions here. John Calloway has a question. Do you have any data on who is causing predation losses? Are there other ways to reduce predation besides removing ravens? And if not, can raven control be expanded to other nesting sites?
Yeah, so the vast majority of depredations are from ravens. That's what we suspect whenever we put cameras on nests. It's typically ravens that we observe taking eggs because they're just so smart. They can find nests really easily. Occasionally, we will get like big predation events where a fox or a skunk or something will go through the colony and wipe out like a bunch of nests in a night. But typically, the consistent predation pressure throughout the season comes from ravens. And uh, I wish there was another way to get rid of the ravens besides lethal removal. But there's been things that have been tried in other places in the range, such as like trying to trick them with other types of nests, like putting out quail eggs for them or like stuff like that. And it sort of works, but it's not as effective as removing them. And the last part of expanding the amount of predator control. So that is something that we're working really hard to try to do, but it's tough to do. Currently, USDA is the only organization that can do lethal control within the sites that we work on, and USDA is spread really thin. So it's hard to get the funding for them, hard to get the personnel on their end to expand predator control, but it's something that we're working on.
There's some questions on plants, so I'm going to try to gather those up. Is there a preferred native plant palette for the adjacent uplands? And do you recommend a limited plant height or taller plants to shield adjacent trails? So maybe speak a little bit about plants in the areas where you see the plover, whether you want them or don't want them and how big you'd like them.
Yeah. So I saw that question. I was very interested by it because we're actually starting a project this next year. Will be the beginning of a project that we're doing in conjunction with our habitats program at SFBBO, where we actually are testing different native plant palettes in like adjacent. That's the word I'm looking for. Adjacent to plover nesting habitat. And I would have to ask Eric, our habitats director, for the exact like seed mix that they're planning on using, but they are limiting plant height. So that is something that we wanted to make sure was taken into consideration because the plovers, like adult plovers, when they're on a nest, they need clear sight lines all around them to be able to see predators coming. So if they're nesting next to really thick vegetation or really tall vegetation, then they don't have as good of a view. And so they're more susceptible to predation. So the seed mix that Eric is going to be using is with plants that I believe stop growing at around like 16 to 20 inches of height. So nothing higher than that. Whereas on the opposite side of the levee, more towards the marsh zone, they're purposely planting higher plants that grow higher because that side is meant to be high tide refugia for salt marsh harvest mouse and rail and all that stuff. So that's where they're planting the taller plants. And then on the side that's closer to the plover habitat, they're planting the lower plant or the lower growing plants. So that'll be stuff like alkali heath, Frankinia salina, I think it's called, alkali heath, saltgrass, stuff like that. On the ponds themselves, it's mostly like a battle against pickleweed because the pickleweed is very effective at colonizing the marsh plain. And so even though it is a native plant, if too much pickleweed grows into a plover area, then we try to rip it back a little bit because once again, the pickleweed grows too tall for the plovers. They like stuff that's really low cover. And then same thing with ice plant. We get a small flower ice plant on the ponds, and that grows nice and low, but it just turns into like a mat, and it's red, not brown. So it's not great for the plovers either. So adjacent to plover sites, going for like low growing transitions, like native plant transition zone kind of stuff. And then on the pond itself, trying to keep that as clear of vegetation as possible.
Thanks. Yeah, I think that covers, somebody had a question about ice plant as an invasive in the bay.
Mm-hmm.
So and not only for plovers, but for a lot of other species that use those levee type habitats, it is an invasive. So Mary wanted to know, I don't know if you have the answer to this, how high plovers can fly?
I
Since
do
they
not
migrate,
know.
right? Yeah.
I do not know. I mean, we're hopefully going to be putting MODIS tags on plovers. I don't know if does MODIS get height? I'm not sure if MODIS gets height data. But maybe I'll have more information about that after this next year, but I don't know. Dave, come on.
David's tagging Ben to see so. Well, this is
No,
really
I didn't mean that as a comparison. It was more like a way of asking whether he knows.
Modus
Yeah.
Presence absence only. Yeah.
Okay. All right.
Yeah.
So I'm just putting a note in the chat. I'm just pinning it right now, or putting, is that Maddie's, well, this is a really great talk, and she'll be working on an annual report. And once that's done, we'll put that on our website. So you'll be able to also dig more into details about this work later in the year once we post it. And I just want to say that we've had these every month now for about 4 or 5 months, and it's really great to see everyone here. We have some upcoming talks, and I just want to make sure everyone's aware that we'll have a talk in February on water quality and harmful algal blooms. Nathan Van Schmidt, Maddie's colleague at SFBBO, will be talking about phalaropes in March. And then we'll hear from Josh Ackerman or Alex Hartman at USGS on breeding water birds. So I didn't want to interrupt the questions, but I just want to make sure everyone knows that we have a bunch of other cool talks coming up. So I'll maybe 1 or 2 more questions, and then Maddie's generously here today, not feeling well, so we'll cut off after that. But yeah, anyone else has a question, feel free.
And I just put the band reporting email in the chat if people are interested, if people have photos of plovers, if people have photos of banded plovers, and you want to report those photos.
Maddie, I think I saw the highest number was 77 people. A lot of people are really, really interested in your talk today. So thanks.
Okay, great.
Much. Yeah. So
I was was going to add just a note on the questions about predator management. You know, there's a fair bit on those. The problem is it's really expensive to do that. Not only is USDA like one of the few approved entities to do that, but they're costly, and this is kind of this kind of thing that the landowners, Fish and Wildlife Service for the Wildlife Refuge or CDFW for Eden Landing have challenges with their sort of degree of available funding to do predator control, whether it's avian or terrestrial, in ongoing years. We did a study a few years back with SFBBO and with UC Berkeley, trying to understand the nature of predation and characterize the which types of predators were the bigger deal, and just to like put a fine point on what Maddie said, and the ongoing source is corvids, right? Again and again, ravens and to a lesser extent crows, sometimes gulls. But then you can just have like this one mammalian predator, like a single individual, not even a species, like and his or her or their family can whip through and just wipe out like major areas. And if we don't have some degree of like fencing or gates or something like that for terrestrial predator control, those things can keep happening because the USDA can't be everywhere all the time the way they can be with avian predators that generally need daylight. So just a couple of things that I wanted sort of pull together some of what we've learned that were asked about in some of the questions.
Thanks for that, Dave. Yeah. So, yeah, Mary Lee says here in Oregon, a single raven or 2 ravens have wiped out entire nesting sites. So, yeah. Well, I'm going to thank everyone for coming. We'll call it a day. Thanks again, Maddy. Give her big congratulations for a really great talk today. So,
Thank you. Thanks, guys. All right.
Yeah, it was awesome, Maddy. Thanks everyone for being here.
I'm gonna go. Yeah, thanks everyone for coming. Okay, bye.
bye.